Assalamu alaikum, students. How are you? How is everything going? And I hope you're enjoying Ramadan. Actually, guys, today I have made a plan to prepare a video for you, especially on circle properties. And these are the last days when your exams are very near, and I'm gonna give you those type of topics revisions which are mostly asked by the examiner, maybe in paper one, paper two, or paper four. So circle properties is one of them. So before I go to the circle properties, guys, I just want to go through with you some basic properties of circles. There are 7 to 8 properties. So let me discuss with you very quickly without any further delay. Uh, Guys, the first property related to the circle is, let me draw a beautiful circle through this. Okay. So this is the circle, boys. And everyone knows circle has a center, circle has a radius. Any line which joins the center with the circumference of a circle directly is called radius. The twice of the radius is a diameter. If you want to draw the diameter, so you can see this golden line is representing a diameter. It is twice of the radius. um, any line, straight line, joins the two end points of this line are cutting the circumference, so such line is called chord. Okay. By the way, diameter is also a chord, but it is passing through the center. So diameter a, is the maximum length of the chord drawn in a circle because it is passing through a center. So you understand what is the radius, what is the center, what is the diameter, and what is the chord. Now, any area which is between the minor arc, what is this minor arc? Let me explain you what is that. Guys, this arc I'm talking about, AB, it is called minor arc because you can divide the circumference into two parts. This is minor arc, and this is, sorry, this one is major arc. Which one major arc? This one is major arc, and this one is minor arc. So minor arc plus major arc is the circumference of a circle. So any area which is enclosed between the minor arc and a chord is called minor segment. It is called, the blue area is called minor segment. And the area which is enclosed between the chord and the major arc, because AXB here, I'm talking about this, boys. This AXB is a major arc. Any area which is enclosed the between the major arc and the chord, I'm talking about this area. This area is called major arc. So I hope you understand that what is the minor segment and what is the major segment. So the area of a circle can be divided into two parts. This is called minor segment, and this is called major segment. The addition of minor segment and the major segment gives you the area of a circle. So let me write it clearly here so that the students can understand. Minor arc plus major arc is equal to circumference of a circle. Minor segment plus major segment is equal to the area of a circle. Now, all the basic terminologies related to the circle, and because we will use them in the properties of circles, you understood them very well. Now, the first property of circle, which I want to talk about, that I'll take the minor arc. This is my minor arc. If I join the endpoints of the minor arc anywhere on the major arc, the subtended angles will be the same by this arc AB. So this property name is angle in the same segment. Angle in the same segment. Because this is your segment, boys. This is your segment. As long as the angles are formed, as long as the angles are formed here anywhere by the arc AB, those angles will be the same. I can make more angles. I can join them here. I can join them here. So these angles are all same. So angle in the same segment. Angle in the same segment. Sometimes it happens that we have been given with the center of the circle. So we join the minor arc with the center of the circle, and also we join the endpoints of the minor arc on any point on the major arc. Okay, so this angle and yani the minor arc, the angle subtended at the circumference, has a relationship with the angle at the center by the same arc. What is the relationship? Double and half. At the center, the angle is always double. So how do you write this property? Angle at the center is twice or double the angle at the circumference by the same arc. This is the second property. Now, third property is, if we have a circle and now we have a diameter. Now we have a diameter. So if any point on the circumference is joined with the endpoints of the diameter, we will get a right angle. Anywhere you join it, you get a right angle. So this property name is right angle in a semicircle. Right angle in a semicircle. This is the third property. Now come to the fourth properties, boys. The fourth property is famous property. You know that a polygon which has four sides is called quadrilateral. But if all the four vertices of the quadrilateral are on the circumference of the circle, then that quadrilateral will be a special quadrilateral, and that quadrilateral is called cyclic quadrilateral. In cyclic quadrilateral, we have a very nice property. That property is the opposite angles are supplementary. If this is y, the opposite to y is 180 minus y. So the name of this property is opposite angles in a cyclic quadrilateral are supplementary. Why supplementary? Actually, what is the meaning of supplementary angles? If the sum of the two angles is equal to 180, then this pair is called the pair of supplementary angles. The sum of the two angles is equal to 180. Then y is the supplement of x and x is the supplement of y. In the same way, there is another terminology which is called complementary angles. Complementary angles, when you add the two angles and their sum is equal to 90-degree, then we say that x and y are complement to each other. We are not using this property, but I'm just telling you that any quadrilateral whose all four corners or vertices on the circumference of the circle, that cyclic quadrilateral has a very famous property that its opposite angles are supplementary. After doing this fourth property, let me take you to the fifth property. The fifth property is, if you have a circle and you have a line which is touching the circle at only one point, a line which touches the curve or a circle at any point, that line is called a tangent to the circle. For example, if this is a curve and a line which is touching the curve at one point is called a tangent line. And you remember, guys, in differentiation, when he was giving you equation of a curve like x cubed plus 3x squared plus 2x, like that, and you were finding dy by dx, which is 3x squared plus 6x plus 2, and that dy by dx was telling you the gradient of the tangent line. This one you can watch it my other video where I explained the differentiation. However, in this property, the fifth property, if he provides you in the exam a tangent line and the tangent is touching at this point, and this point is called point of tangency, and I have a radius, a radial segment is drawn on the tangent. So the relationship between radius and tangent is they are 90-degree to each other or perpendicular to each other. So in the exam, if you want to say what is the logic behind it, you will simply say radius is perpendicular, or use the perpendicular symbol. Radius is perpendicular to tangent. This was my fifth property. Now come to the sixth property. The sixth property is recently added in the course. If you have a tangent and if you have a chord, not the radius, chord. Now, the angle which the chord is making with the tangent is the same as if you produce the chord back on the circumference at any point. If you join any point um, in the other segment, because we have two segments, I'm not talking about this segment, I'm talking about this segment. So in this segment, if you find any point on the major arc or whatever, or on the circumference, if you join the end points of the chord there, then this angle is the same as which the chord is making with the tangent. Likewise, there is another chord you can see here. This is also a chord, and this chord is making an angle here with the tangent. And now you can see that this chord is making angle here. So these two angles are also same. And the name of this property is called alternate segment theorem. Alternate segment theorem, or some people call it as tangent segment theorem. Any name you can use it for this, tangent segment or alternate segment theorem. Next property, guys, if you have a circle and there is a point outside the circle, you can draw two tangents from it, one and two. So there are two tangents. This is A, this is B, and this is B. As per the rule, the tangents have same length. AP is equals to BP, same length. Second thing is, this is 90-degree, and this is also the radius. The two radii, they are at 90-degree to the tangents. And another property, that this angle x and this is 180 minus x, they are supplementary to each other. Or you can make two congruent triangles, and this angle is the same as this, and this angle is the same as this. So two right angle triangles, it looks like a rhombus as well. Not rhombus, kite. OAPB. So this triangle area is the same as the other triangle area, and also they are congruent to each other. The most important property is this, that the lengths of AP and BP are same. Another property, boys, that if you have a circle and if you have a tangent here and you have a center, if you drop a perpendicular on this chord, then it cuts the chord into two equal halves. So this property can be used in vice versa situation, that if uh, if a chord is cut by a line, and cut it into two equal parts, then the line will be perpendicular to the chord. So this is A, this is X, and this is B, and this is C. So guys, AX is perpendicular to BC, implies that BX is equal to CX. So this is very, very important property. And if you join A with B, then you get a right angle triangle, and Pythagoras theorem and trigonometric ratios comes to your mind. Uh, One more property comes to my mind regarding the symmetrical properties of circles. That if you have a circle and if you have two chords, now amazingly, guys, if the two chords have same length, then they must have same distance from the center. Got it, boys? So y y this y, I'm talking about this y, this is y1 and this is y2. So y1 is equal to y2 if x1 is equals to x2. And if the lengths of the chords, if they are same, then the distance of the chord from the center will also be the same. And I think I discussed approximately all the properties of circles. If anything is left, guys, I will repeat it when we will do the questions related to those properties. And inshallah, I will also try to revise question by question the properties which I discussed with you. Don't worry, they are the 7 to 8 properties, but inshallah we will do them. Now, when in the exam you see the question on circles, you have to see what are the things given to you. Number one, the guy has provided you the diameter. So if the guy has provided you the diameters, it means that this is 90 degrees. So the right angle in a semicircle. So if the guy provides you in the exam diameter, so the end points of the diameter can be joined anywhere, you get a 90 degree over there. So this is 90 degree. So this is 90 degree. Second property, which is very, very important, the alternate segment theorem. You guys can see that there is a tangent and there is a chord, and the chord is joined back here on the circumference. So, as we discussed before, that the angle between the chord and the tangent, it is always the same, which the chord is subtending at the center. This angle I'm talking about. So, this has to be 42. So, guys, imagine we have found this is 42, this is 90, and as per the rule, guys, this is radius and this is tangent. They are also 90 degrees. I didn't read the question. I actually wanted to give you everything which is contained in the question. So, three properties I used: radius is perpendicular to the tangent, alternate segment theorem, and right angle in a semicircle. So three properties. I don't know what he is asking you. He said that find the angle PQ PQ PWQ. Sorry, PWQ. So didn't I say that this angle is 42? because this is 42 alternate segment theorem. So you call it 42. And what is the reason? Alternate segment theorem. Number one, and I think this question is taken from the exams earlier than 2020. So at that time, maybe they were not using alternate segment theorem. So this question can be done also in this way. How this is radius and this is tangent. So radius and tangent are 90 degree. So this is 90. So 90 minus 42, boys, will give you 48. So this is 48. This is 90 degree by the property of right angle in a semicircle, because diameter was given, and we can find the third angle. But this is a long procedure. 180 minus 48 plus 90 degrees, boys, and I can get it 42. So did you see that you can use any property to get to the question? So I just write it here, 42, and I highlighted that I use which property? Alternate segment theorem. However, if the other students want to use some other properties to reach to their final goal or final angle, they can go for this. Now, this question, interesting. Um, you remember I told you when the central angle is given to you and the back angle is given to you, there is a relationship between them. But because which arc is used, AC arc is producing angle at the center, and also it is making an angle at the circumference. So center and circumference, what is the relationship between them? At the back, angle is always half of the central angle. So 110 divided by 2, it will give you 55. So this angle is 55. Done. So we found x55. The reason behind it is the angle at the circumference is half of the angle at the center, subtended by the same arc AC. Now I want to find why. Guys, can you check? Do you have all the four corners of ABCD on the circumference? The answer is yes. So, can I say ABCD is a cyclic quadrilateral? Yes, ABCD is a cyclic quadrilateral. And what is the famous property of cyclic quadrilateral? The opposite angles are supplementary. So, fifth, y will be what? Y will be 180 degree minus 55. So let me do the subtraction. 180 minus 55 will give you 125. So I'm going to write here 125. In this question, guys, I can see the central angle. This is the central angle, and the same arc is making an angle at the back. The relationship of the central angle and the angle at the circumference, we know that this angle W will be the half of 108, which is 54. So we found W 54. After finding this, let me erase everything and write here 54. Now, do we have anything which is given? It looks like you have been given a cyclic quadrilateral. Let me highlight those sides which are making a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral, and X is the opposite angle of 54. We use the property of cyclic quadrilateral. The opposite angle of 54 is X, and we will write 180 minus 54. 180 minus 54 gives you 126. So 126, I'm going to write it here. Now, after doing this, we want to find y as well. Let me erase. This was 54. 4, and we found 126. Guys, you can see there is a straight line. BCE is a straight line, and CD is making an angle with the CE, which is 60 degrees. Can I take the opposite of this? The straight angle, or the supplement of 60 degree will be 120, because the total is 180. So I found the angle BCD, which is 120 degree. Again, use the cyclic quadrilateral property. The cyclic quadrilateral property, y will be equals to 180 minus 120, which is 60 degrees. So here you go. This question, um, he has given the central angle to us, arc, this arc, and he is joining it here on the circumference. The relationship between the circumference, the central angle and angle at the circumference, that this is half of that. So I'm gonna just very quickly write this angle for you. So this is 104 divided by 2, which will be 52. So let me copy here. This is 52. Now I want to find W. To find W, guys, can I find this angle quickly? Because this angle is the same as this. They are vertical opposite angles. This angle I can find 180. 180 minus the sum of 21 and 104 gives you 55. So this angle is 55. So this has to be 55. I can easily find W. So W is equals to 180 minus 55 plus 52 will give you this angle. So 180 minus 55 plus 52, and finally we get 73 degrees. This question, BEC angle we want to find. Let me highlight where is BEC angle. BEC. So the central letter is E. So I want this angle. Guys, do you agree with me that BC arc is making angle on the circumference 19, and it is also making an angle at E? Can I say both of them are 19 by using the property which is called angle in the same segment? So I'm gonna write this angle, because these angles are made by this arc on the circumference. So this is also 19. First angle is 19. Now the next question is, I want to find ABC angle. Erase everything. ABC angle. ABC. So this angle is this one, ABC. It gives me a sense to use cyclic quadrilateral property. But before that, why not we can use the same property which we use in the previous part. So AB is going to make angle 23 here. So it will be definitely making 23 here. So this angle is 23. Now erase everything. Now I want this angle ABC, this angle. The opposite to this one is 25 and 19, then this angle is given. Do we have this triangle cyclic? A, AB, BC, CE, and AB cyclic. In cyclic quadrilateral, opposite angles are supplementary. So I can easily find this angle 180 degree minus 25 plus 19. So let me get it. 180 minus 25 plus 19 gives us 136. Big angle, obtuse angle, 136. Now, after finding 136, let me erase. So the total angle was 136. Can I find this angle as well? So 136 minus 67, 69. So this angle is 69. Anyways, next, I want to find BCE. Where is BCE? BCE. Oh, wow. So I know the two angles. I know this is 19, this is 69. I can easily find the third angle by using the angle sum of a triangle. So 180 minus 19 plus 69. So it gives us 92. So this is 92. Next question. Wow, the symmetric property of circles. We have two chords. Look at that. AB is a chord and DE is a chord. Let's see what he has provided us. He said M is the midpoint. Wow. If M is the midpoint, my friends, then it means OM should be perpendicular to AB. He also said N is the midpoint. Then it means OD, OE, and OD and OE are the radius, and ON is perpendicular to DE. So we want ON. What are the dimensions given to me? He said AB is 9, AB is 9, and DE is 9. Okay, so let me write here 9. So this should be 4.5, 4.5, 4.5, 4.5. OM is 5. OM is 5. This is also 5. And I want ON. Okay, right? So we are ready to find. We found it, I think. Yeah, OM is 5. So ON is also 5. It's 1 mark question. The reason is he wanted it because the lengths are same. So they are perpendicular. They must have the same distance from the chords. So we use this property. This is 5. But he could have asked you what is the radius of a circle. So if you want to find the radius of a circle, you could have said that 4.5 squared plus 5 squared by using the Pythagoras theorem. But this is an extra work. This is an extra work. It's not needed. So as I said, my friends, that the chords have same length, so the distance of the chords from the center must be the same. So if this is 5, so this is also 5. No need to do this extra work. Just simply write 5. This question, if you look at question number 7, he gave you the center. Center is O. Let me focus on this triangle OAB. Yes, it looks like an isosceles triangle because OA is the radius and OB is the radius. And there is a very famous property of isosceles triangle. If the two sides are same, their opposite angles are also same. So this angle should be 2x. Let me erase everything. Okay. Now see the question. The very first question, we want to find AOB. Oh wow. AOB. This angle we want to find. This angle. In terms of x. So there is no numerical answer. We are going to get the answer in terms of x. So this angle will be what? 180 degree minus 2x plus 2x. So 180 minus 4x. 180 minus 4x. We found it. So this is 2x. and this is 180 minus 4x. Now we want ACB angle. Where is ACB? ACB, the letter C at the center. So we want this angle. You remember, boys, the relationship of the angle at the center and angle at the circumference by the same arc. The circumference angle is always the half. So 180 minus 4x divided by 2. So when you divide it by 2, the 180 divided by 2 will give you 90, and divided by 2 will give you 2x. So 190 minus 2x. So 90, the half of 180 minus 4x is 90 minus 2x. We found it. Clear, boys? We found our answers. Now, angle DAB. DAB. Let me erase 90 minus 2x. DAB. DAB. This angle we want. Wow, can we use the cyclic quadrilateral property, because this triangle is cyclic? So we know this angle, we can easily find this angle. How? How can we find it? We will say that 180 minus 90 minus 2x. So open the brackets, this minus changes to plus, so plus 2x, it comes to me 90 plus 2x. So 90 plus 2x. So we found this answer. Okay, guys. Next is two parallel lines are given. You know that if the lines are parallel, we can use the z concept. What is the z concept? This is the z concept. So this x should be the same as 47, and the name of this property is alternate pair of angles. So x should be 47. Next, we have a quadrilateral, and he gave us this angle. Uh, all of you remember that the sum of all the interior angles, the sum of all the interior angles of a quadrilateral, they are the sum is 360 degrees. So I can easily find this angle 360 minus 97 plus 115 plus 85. We find this angle first and then subtract it from 180. So 360 minus 97 plus 115 plus 85, it gives us 63. So this angle is 63. Then y will be equal to what? Y will be 180 minus 63. 180 minus 63 gives us 117. This question, interesting. The reason is we want this angle, the central angle is not given. So the total angle is 360. From 360, I will subtract z and write 360 degree minus z. Or some students can make a cyclic quadrilateral, and this is 58. They can write this angle 180 minus 58 will give them 122. And you remember that 122, the double of 122 will be z. So 244. This is one way of solving this question. Second way is you can find this angle first, which is 360 minus z, and you know that 360 minus z will be equals to the twice of 58, and it will give you the same answer. So this is 244. This question might be very important for you. Oh, guys, an application of similar triangles. I want to show you that how the two triangles are similar. And in my in my video of similar triangles, I told you when the in similar triangles all angles are same. How here the two triangles are similar? Let me explain you. Number one, this angle. You agree with me that this angle x, yani AXD, is the same as BXC. These two angles are same, right? Because they are the vertical opposite angles. They are the vertical opposite angles. Second is this angle is the same as, come on, tell me which angle? This angle. What is the reason? If you are using an arc AB, if you are using an arc AB, boys, so the arc AB will make same angles on the circumference, angle by this angle in the same segment. This is the reason. So angle C is equal to angle D. In the same way, my friends, this angle A will be the same as angle B. Which property I have used in the circles? BC arc makes the same angle on the circumference at A and B, angle in the same segment property. So if the three angles in one triangle is equal to the angles in the second triangle, we say that the two triangles are similar. But which point is corresponding to which? A is corresponding to B, D is corresponding to C, and X is corresponding to C. So the ADX triangle, guys, is similar to which property? Angle property. Which property? Angle property allowed us to write that the two triangles are similar. Whenever you do similar triangles, guys, I told you that he's gonna compare the two triangles. So the ADX triangle, boys, and the BCX triangle. ADX triangle area is given to you 36, and the BCX is 65.61, and he said AX is 8.6. This is 8.6, and dx is 7.2. Dx is 7.2. I want which side? I want bx. So bx is opposite to the red angle, and which side is opposite to the red angle? 8.6. So x corresponds to 8.6. So 8.6, and here I will write x. On the top of the areas, I will write 1 over 2. I already explained it to you why we do this thing. If the lengths are to be found and you have been given the areas, so on the area ratios, you always put square root. So it's the area of ratios, and this is the ratio of the lengths. So you need to put square roots on them. But if the lengths are given, you always put squares on them. So square root we put on them and do the cross multiplication. So let me get the value of x from here. X is equal to 8.6 into square root of 65.61 divided by square root of 36. Let us write it together. 8.6 times square root of 65.61 divided by square root of 36. It gives us 11.61. Now, these two triangles are also similar. The reason is that we have basically two triangles, this brown small triangle and the green big triangles. Why these two triangles are similar, my friends? Because this side and this side, they are parallel. If these two sides are parallel, my friends, then we can say that A is also 63, and the name of this property is corresponding angle. So 63, this is 63. This is 58, so this is also 58. We can easily write B, which is 180 degrees minus 63 plus 58, and then we can get the angles. So B is corresponding angles, and A was 63. 180 minus bracket open 63 plus 58 will give us 59. So this is 59. Reason is angle sum of a triangle, which is 180. Question number 10. We want to find angle ABC. ABC, this angle we want. Let's see how can we get it. My friends, the guy has given you the tangent, and the guy has already given you the chord. So AC chord and PCQ is a tangent. Did he join the chord anywhere on the circumference? Your answer will be yes. He is joining at D. And do you remember which property I have taught you? By the alternate segment theorem. This is 64. So that has to be 64. Wow. So this is 64. Now, may I ask you, are these vertices on the circumference of the circle ABCD, if we join them together, are we going to get a cyclic quadrilateral? The answer is yes. So do we have D opposite to B? The answer is yes. So 180 degree minus 64, cyclic quadrilateral property we will be using. So 180 minus 64 will give us 116. So 116, two properties I used. First one was alternate segment theorem. Second property is opposite angles in a cyclic quadrilateral are supplementary. Next, question number 11. Very quickly, guys, X and 56. You know that the arc AB is making angle at the center, and also it makes the angle at the circumference. The relationship between the central angle and the circumference is very clear, that the central angle is always bigger. It is the double. So 2 times 56. So 56 times 2, 112. We found it. So let me erase. This is 112. Now, my friends, still I'm going to use the same arc AB and the central angle. No need to use the central angle, guys. I can easily find why. How? Same arc. Look at that. The arc is joined at Q. The arc is joined at B on the same circumference. So angle in the same angle in the same segment. So if this is 56, so this should also be 56. It was pretty simple. Angle in the same segment property, I have used it. So that was 112. Next, will you allow me, guys, to quickly use the isosceles triangle property, because you know that OA is the radius, OB is the radius, so these two sides are same. So I can say OAB is an isosceles triangle. The opposite angles of isosceles triangle are same, 28. I can easily find this angle, 180 minus 28 plus 28. Let me get to the calculator. So 180 minus 28, 28 plus 28, it gives us 124. So this angle is 124. My friends, arc AB, central angle is 124. and the back angle on the circumference, is there any relationship? The answer is yes. This angle ACB is the half. So 124 divided by 2 will give you 62. So this is your 62. So please name the properties which you have used. I used what? I use property of isosceles triangles. What was the property I used it? Opposite angles are same. um Opposite angles are same. You can write it, or angles. You can also write here angles opposite to the same sides are also same. It's up to you. How do you understand the property, and how do you convey it to the examiner? But angles opposite to the same sides in an isosceles triangle, they're also same. Second property which I use it, guys, here: angle at the circumference is half the angle at the center by the same arc. Anyways, question number 13. Oh, we found two parallel lines. So the Z concept. What is the Z concept? Look at that. A, D, B, C. So this is U. So this is also U. Wow. Next. Uh, do we have any other property given by him? So we use the property of parallel lines. Secondly, I can say that this is also 35, because we have again parallel lines here. Z concept 35. So let me write this. This is U. Now, my friends, tell me quickly. Uh, is this angle at D same as the angle here? And the angle here, this U, will be the same as angle at A, 35. So U is equal to 35, angle in the same segment, 35. So this is also 35, right? And as per the parallel lines, this is 35 and this is also 35. Now I can easily find V. V is equal to 180 minus 35 plus 35. The interesting property here in this question, he used the circle properties plus the parallel lines properties. The mixture of them has made this question, and the students can, inshallah, easily solve it in the exam. So that is 110. I like this question. Next, can you get this angle very quickly, guys? Now my pace will be a little bit higher, because I do feel now you guys are on a smooth track. You understand, you started understanding the questions and the properties applications. So 150. So this is 150 divided by 2, 75. Did he mention to write the properties? No, he didn't say anything. So as you see, that was total 360. From 360 I subtracted 200 and 210, which gave me 150, and then I use the double half properties. Now first is W. I want to find W. Can I see a cyclic quadrilateral here? Tuck, 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 tuck. Yes. Which angle is opposite to 140? That is W. So they are supplementary. So W is equal to 180 minus 140. It comes to me 40 degrees. So now let me erase everything and write here 40 degrees. Next, I want to find X. So shall we look again into a cyclic quadrilateral, the second cyclic quadrilateral, which we can see in the circle. So I want to find this X. What is opposite to that? The opposite to that is this one. Oh, can I find this small angle? The answer is yes. First, try to find this angle. So 180 boys minus 40 plus 95. So 180 minus 40 plus 95 gives me 45. So if this is 45, so 45 plus 40 is 90. Is it 95 or 85? It's 85. Now I can find X. 180 minus 85 will be 95. 95. So I got X 95. This was 40. Anything left? Y. Where is Y? Yeah. Allow me to erase this. I want Y. What is given to me? Uh, Guys, let me check. Do we have cyclic quadrilateral? Any other cyclic quadrilateral? I think yes. We can use this property. Hold on, guys. Uh, I'm gonna use a cyclic quadrilateral here. This is a cyclic quadrilateral. Opposite to 140 is this is 40. Wow. Now the question is pretty simple. We know now that this angle was 95. Concentrate only in this triangle. If you know the two angles, you can find the third one. So y will be what? Your y will be 180 minus 95 plus 40. 180 minus 95 plus 40. It gives us 45. So y is also 45. Did he ask for any proper reason? No. Next thing, you remember, guys, when a chord is given and any line which is joining the midpoint, did he mention here? He said M is the midpoint. Wow, so it means that it is perpendicular. It is perpendicular. So OM is 4.5. AB is 12, so it is cutting at half, 6 and 6. Can I find the radius? Didn't I mention in a previous question when this type of a property was used, examiner may ask you what is the radius of a circle. So radius using Pythagoras, radius is equal to the sum of the squares of the two shortest sides, 4.5 squared plus 6 squared, and then you get your radius. Next, question number 16. I want to find W first. Where is the W? Here is the W. So can I use cyclic quadrilateral? Yes, the cyclic quadrilateral, which I'm going to use it here. Here you go. Yeah. So the opposite of E is W. So 180 minus 85, the opposite angles in a cyclic quadrilateral are supplementary. The answer is 95. Let me show it to you from the calculator. It gives us 95. Okay, allow me to erase and write here 95. Now, next, X I want to find. Again, I can feel there is a cyclic quadrilateral. This is a cyclic quadrilateral. And the opposite to B is this 95. So I'm going to use here 180 minus 95 it gives me 85. So two times I have used the cyclic quadrilateral because we can see the two cyclic quadrilaterals are forming over here. So this is 985 now. Anything which is left? Y. Now, guys, if you know the two angles in a triangle, you can find the third one. So y is equal to 180 minus 85 plus 47. So 180 minus 85 plus 47 will give you 48. So y is 48. No reason is required here. Uh, this type of a question we have already seen. Problem is this, that I can't find this angle, and please, 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 this is not a cyclic quadrilateral because A is on the circumference, B is on the circumference, C is on the circumference. However, O is not on the circumference, so this is not a cyclic quadrilateral. So guys, how can I find this angle? Because if I use this arc, the central angle is this, and the half angle will be, the half of that is 130-degree given to us. So I can say that this angle 130 times 2. So 130 times 2 gives you 260 degrees. So my friend, this angle is 260, the reflex angle. Can I find this angle, which is 360 minus 260, and it gives you 100 degrees. So I'm going to write here 100. And I want to find the obtuse angle AOC, because there are two types of angles, my friends. AOC. This angle is reflex. This angle is reflex. And the corresponding angle here is obtuse. Examiner didn't mention he wants the reflex angle. The reflex angle is 260, but the obtuse of AOB is 100 degree. Here we need to write 100. Next, question number 18. Guys, I will do this question directly. Did he mention anything interesting? Yes, yes, diameter JL. Diameter JL. Did he join the endpoints of the diameter anywhere? He joined it at M. So it means the 90 degrees happening over here. This is 90 degrees, boys. This is 90. Now, he said this is 104. So this is also 104. Which angle we want to find? We want to find angle D. So, my friend, if you want to find angle D, let's go to it step by step. How much marks it has? It has 4 marks. Number 1, can I say if this is D, this is also D? Any objection? Because he has used this arc, making angle D here, and also it makes the angle D here. So I labeled the two angles as D. Next, can I label this one as 104 because they are the vertical opposite angles? Can I get this angle, boys, because the two angles are known to me? 180 minus 104 plus 22, it gives us 54. So this angle is 54. And since it is a diameter, didn't I tell you that this is also 90 degrees? So D plus 50 is 90 degrees. This is 90. So D is equal to 90 degrees minus 54. So 90 minus 54 gives you 36. Very, very interesting question. Next, question number 19. He gave you a circle question in which we want to find x first. I think x is very simple, very, very simple, because he used this arc AB. Central angle is given and the back angle is half. So 110, that should be 55, because 110 divided by 2, sorry, divided by 2, so 55. We found it. And this arc, if we join it here at the circumference, again we join it at the circumference, angle in the same segment, so the y should be equals to 24. So 55 and 24. Question number 20. Similar triangles. Oh wow, in the circle, similar triangles. Who gives me an idea that there is a similar triangle situation? Because we have the two parallel lines, so which angles are same? This angle is the same as this, and this angle, and the corresponding angles. Now, I want to find the radius of the circle. How can I find the radius? Did he mention anywhere radius? Oh, yes, AD is a radius. So, AD is a radius, then it means this angle is 90 degrees. So, this is also 90 degrees. Done? Uh, I want to find. AD first. So because AD is required, if I get AD, then it would be easier for me to take the half of AD, which is the radius of a circle. So how can I get AD, my friend? I have a big triangle, I have a small triangle. So the big triangle, one dimension CD is 18, and the corresponding side is 13.5. I think you have no problem. Now, my friends, another side which is given to me here, AB side, which is for the smallest triangle, that is 21. So if it is 21, I can find the big triangle AC. AC, I can find it. Look, this is AC. I can find it. Don't worry, I will find AC. Since I'm comparing the lengths, no need to put squares on square roots or cube roots. So AC will be equals to 18 times 21 divided by 13.5. So I'm going to take the ratio 18 times 21 over 13.5. It gives me 28. Wow. So AC is 28. My friends, how can I get AD? Don't you think ACD is a right angle triangle? The answer is yes. ACD is a right angle triangle. So if ACD is a right angle triangle, you know this. You know this. You know this. Can you find hypotenuse, boys? Hypotenuse is equal to what? It is the square root of the sum of the squares of the two shortest sides. So the one side is 28, which is AC. This is 28. And the other side is 18. So please, you use the calculator here to get your hypotenuse, which is basically a diameter. 28 square plus 18 squared will give us this thing, 33.287. 33.287. Now please divide it by 2. It will give you 16.6 to the three significant figures. So 16.6, that is the radius, because everyone knows that was diameter, and that diameter was AD. Basically that was AD, but we want to find radius, so divided by 2 will give you the final answer. I hope my calculation was right. Now come to the question number 21. In question number 21, examiners gives you a tangent, and he gives you a chord. You remember the alternate segment theorem. If it is joined back on the circumference, this angle is also x. So what is the reason I can code it here? So the x, any angle QPR, which letter is at the center? P. So QPR is x. Why? It is alternate segment theorem. Alternate segment theorem. This is x. Second thing, he says that um, using we need to prove that PQR is an isosceles triangle. Let's see. Did he give us any other thing? He said, oh, yes. He said QR is bisecting the angle PQB. Look at that. This is PQB, and QR is a bisector. So bisector means it cuts the angle into two equal halves. So this is half and this is half. So this angle is yani this angle and this angle, they are the same. If this is x, so that is also x. So what I'm going to say that since he says that the bisector, the angle P, guys, keep the Q in the center. PQR angle is the same as x. The reason is it is given. It is given in the question. You can mention it here. This is given. If in a triangle two angles are same, then that triangle is isosceles. So triangle, which triangle? PQR is an isosceles triangle. What is the reason? Is an isosceles triangle because the two angles are same. The two angles are same, and x is less than 60 degrees. He wanted to mention this property that x is less than 60 because it cannot be equilateral. He is not trying to say that it is not 60, because if it is 60, you know that every angle will be 60. And this is 60, this is 60, this is 60, then it will become equilateral. He wants to deny that fact. Only the two angles are equal. So that if the two angles are equal, then we can say that it's an isosceles triangle. Just mention it here. Then also x is less than 60. It is not equilateral. It is not equilateral. So this is purely two sides equal, then opposite two angles are all. If the two opposite angles are equal, then PQ, yani this side, will be the same as this side. So PR is equal to QR. So PR is equal to QR because their opposite angles are same. I think this question we did it before, but let me check ON. I think we did it. So this was 5. So ON is also 5. Just quickly we can write the answer. Next, 22. How many questions, guys, we have total? Let me check. 28, 20, 30, 31, 32, 33. Oh, man. Oh, 39, 40, 41, 42. Okay. I will move fast. I will definitely move fast to finish our circle properties questions. In this question, you see, guys, he said ADC angle you want to find. ADC. This angle is required. Okay. Cyclic quadrilateral property, we can use it. So x plus 20, because this angle is opposite to 131. So is plus 131 is equal to 180. So let me simplify. 180 minus 131 minus 20, it gives us 29. So x is 29. We found it. 29. We found this angle 29. So this angle is 29. We call it x. Okay, so this is 29. We found it. Total is how much? Total is 49. This is 29. AOC, guys. Central angle, he's asking you. AOC. And did we find the back angle? The back angle was 49. We found it. So we need to take the double of this. So 2 times 49 will give you 98. So this is 98. We found AOC angle. Then BAT. BAT. BAT is this angle. BAT, the chord. What is the chord making an angle on the circumference? It is making 20-degree here, so that should be 20 degrees. Reason is alternate segment theorem. Next, OAB. Guys, you remember OA is the radius, and this is your tangent. They are making 90 degrees. So I want to find angle OAB. OAB. So this angle is 90 minus 20. That will give you 70 degrees. Next, we can see easily in the question there is an isosceles triangle. We want to find the value of x. First, check which property can be used here. He has given the angle between the chord and the tangent. It is 47. So I will write it here also 47. Then he gave you 25. This should be also 25, angle in the same segment. Now, since it is isosceles, so both angles are same, can I add them up together? 47 plus 25, 72. So this is 72, my friends. This is also 72. So x will be equals to 180 minus 72 plus 72. And then I can get my answer. It's 36. So that is 36. Now next, you remember that, guys, these two angles are supplementary. Any this AD is equal to DC. The tangents have same length, and these opposite angles are supplementary. 180 minus 44 will give us 136. And then you remember that this angle and this angle, they have a special relationship. The x is half. X is half of 136, which is 68. Now you want to find angle TPQ. Where is TPQ? This angle. Alternate segment theorem. This is the chord and this is the tangent. So this should be 50. We have isosceles triangles, so opposite angles to the equal sides are also same, 50. So I can easily find 150 minus 50 plus 50, which is 80 degrees. Now, cyclic quadrilateral. First find this. 180 minus 68 gives you 112. Okay, then opposite angles are supplementary. So W is 112, and 2x plus 3x is 180. Then 180 divided by 5 gives us 36. So x is 36. 26. We have to find x. X is same as 55. Alternate segment theorem. Another tangent from the point S. Oh yes, another tangent from the point S is drawn. Touches the circle at V. Give a geometrical reason why triangle SVR. SVR. will be isosceles because we know SV is equal to SR. SV is equal to SR. The tangents have same length. Tangents have same length because whenever you have a circle and from outside a point you draw the two tangents, their lengths is always same. So in this case the TV is equal to SR. That's the thing. Next, parallel lines are given. Be careful, boys. We have to use the properties vertical opposite angles. So A is equal to 126. Then this is B. And you remember, guys, the C concept. When we have the parallel lines, these angles are supplementary. So B will be equals to 180 minus 126. It gives us 54. Now, once we find this one, again, we can use um, the supplementary property. So C is equals to 180 minus 63, 117. Parallel lines again given, so we need to know the alternate angles. This is X, that is also X. 58, it's a diameter, so this is 90 degrees. We can easily find X. Your X will be equals to 180 minus 90 plus 58. So 90 minus 50, 58 gives me 32. So X is 32. What are the reasons I used? First, alternate pair of angles. Number two, uh, right angle in a semicircle. Right angle in a semicircle. And then the third property, angle sum of a triangle. That the sum of the three angles is 180. So angle sum of a triangle. So three properties I use to get the value of X. This question we have seen many times, guys. What is this? This is 2y, because if the angle at the circumference is y, so the angle at the back will be 2y. Now, what is the relationship between 2y and 142? So 2y plus 142 is equal to 360. We simplify it. 360 minus 142 and divided by 2 will give you 109. Oh, polygons. Guys, whenever the word polygon, the regular polygon comes, we have a very famous formula for regular polygons only. You always write here E for exterior, single exterior angle. Here I write 360 and this is number of sides. Interior angle plus exterior angles, they're the corresponding exterior and interior, their sum is always 180. They are supplementary to each other, so don't bother. I don't know interior. Once you get the exterior, you can easily find the interior angle. Okay, now what's the question? The interior angle of a regular polygon in n sides is 150. Wow, so the number of sides are given to me. Interior angle is given. Interior angle, Sheikh, interior is 150. I can easily find exterior because exterior is supplement of interior. 180 minus 150, it gives me 30 degrees. So now you know your interior angle. Astaghfirullah. Exterior angle is found. So I want to find the number of sides. So 360 divided by the exterior, which is 30 degrees. So let me do the division. 360 minus 30, it gives you 330. Division 360 divided by 30 gives us 12. Yes. Now we have this B part. We can see isosceles triangle. This should be Z by alternate segment theorem. This is 90 degrees, and this should be Z, guys, because you know that the radius, um, the isosceles triangle, the opposite angles are same in front of the equal sides. Also, you know that this is 90 degrees, so Z should be 45. Z should be 45 because Z plus Z is equal to 90 degrees, so Z is equal to 45. Next, 80 is tangent. So this is 58 by alternate segment theorem. This is also 58. And then I can easily find x. As you know that x is equal to the sum of the two interior angles. Uh, you can find this angle first and then subtract it from 180. But I know that the sum of the two interior angles is equal to the opposite exterior angle. So if you know this is 27 and this is 58, you can write this exterior angle. This is equal to the sum of these angles. So this concept, basically, I'm using it here. So 58, 58 plus 27 gives you 85. Parallel lines are given. Be careful. Um, First, I will try to find this angle, 180 minus 108, which is 72. I can also find this angle because in parallel lines, the C concept is this. Look at that. If you have two parallel lines, same side interior angles, they are supplementary. They are supplementary. So I can find this angle, which is 180 minus 72. It's 108. And now cyclic quadrilateral property. So y is equal to 72. Next, reasons why they are congruent. Congruent means same triangles. And we have famous four properties of congruent triangles. We have um, triple S property, the three sides must be the same, angle side angle property, angle side property, and RHS property. These are the four properties for congruency. If the three sides of one triangle are equal to the three sides of the other triangle, we say that by the property of triple S, yani the three sides, they are congruent. Congruent means those shapes which are totally same. If you can put on top of each other, they will exactly match to each other. Now, what are the conditions given by him in this question? He said that OM is equal to ON. OM OM is equals to ON. So the two sides are same. Sorry, the distance of the chords AB and DC from O are the same. OM is equal to ON. M is the midpoint of AB. Oh, good. And N is the midpoint of CD. Done. These are the things given by him. According to the property, this must be 90 degrees. Okay. And I can say that OA is perpendicular and is the same as OD because this is radius and this is also radius. This is radius. Why OAB triangle is congruent to OCD? Clear, boys? So which property we should mention it over here? This property tells us that whenever we have Yani, he said O M is the midpoint. He said M is the midpoint. It tells you that this is X and this is X. It tells you this is Y and this is Y. Clear? And then we know that this is R, this is R, this is R, and this is R. Clear? Second property, which is very important to us, if we will able to produce that the X is equal to Y, then we can say with triple S property both triangles are same. Since OM ON is equal to OM, right? And OM is, yani, M is the midpoint. M is the midpoint of AB, and N is the midpoint of, so the midpoint property used, and we can write here. So ON is equal to OM, ON is equal to OM, and AB is equal to DC. The reason is OM and ON are, or I can write it here, M is the midpoint of AB, M and N are the midpoints of A and B respectively, of AB and DC respectively. Now, if M and N are the midpoints, so it means that the midpoint property told us they should be perpendicular to each other, their distances are same, and I can say that AB, yani this property says that AB is equal to DC. Now, from the figure, it is given to you ON is equal to OM, AB is equal to DC, and also OA is equals to OD. What is the reason? They are the radii, so the common radius. They are the radii. Again, Bismillah Rahman Rahim. OA is the same as OD, number one. Let me write everything again, then you will not have any ambiguity in your mind. OA is equal to OD. What is the reason? They are the radii of a same circle, or radius of a circle. Again, OC is equals to OB. OB is equals to OC. What is the reason? Radius of a circle. Done. Now, I say that AB is equal to CD. AB is equal to CD because M and N are the midpoints. M are the midpoints of M and N are the midpoints of AB and CD. Also, ON is equal to OM, and by the RHS property we can say that they are equal. The main properties are OA is equals to OB, OB is equal to OC, and AB is equal to AD. These two triangles are triangle OAB is congruent to triangle OCD. The reason is triple S property of a triangle. Right? Next, question number 29. Uh, Question number 29, if you look into this, he has given a very complicated shape. First, we need to find V. V. Guys, this is the chord and this is the tangent. Did he produce the chord at back? Yes, this is 40. So V should be 40. Next, we want to find W. W is, boys, we can see, did he provide us any information about W? Did he say anything equal? Yes. He said EC is equal to EB. EC, EC is equals to EB. So it looks like an isosceles triangle. If the sides are same, their opposite angles are also same. So that has to be 80 degrees now. 80 degrees. Now, this is done. Now I want to find X. So if you want to find X, X should be 40. The reason is this arc is subtending angle at the circumference 40, and also it is subtending angle at D. This should also be 40. Next, Y. Can we use the cyclic quadrilateral property? Let me show you which cyclic quadrilateral now I'm choosing. Now I'm choosing a cyclic quadrilateral here. Let me show you which one. I'm going to choose this, 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 and this. So the opposite to 80 is Y. So 180 minus 80, that will be 100. So I'm going to write here 100. Next, Z. Let's try to use another cyclic quadrilateral. This cyclic quadrilateral. And this angle is how much, guys? 40 plus 80 is 120. So that has to be 60. Okay. So we are done. This is 40. Angle KML is 2x. So reflex angle is 11x. This is reflex 11x. This angle will be what? Double 4x. So 11x plus 4x is equal to 360. So 15x 360. Then you can easily find the value of x. Next, 30. In question number 30, guys, he says you need to find x. So x is easy. Half angle. 162 divided by 2, which is 81. 81. Angle at the circumference is half of the angle at the center subtended by the same arc. Okay. Angle y. Angle y, we want to see what is angle y. Let me erase. We want to find this angle y. It is made by this chord. Can you check that by alternate segment theorem? If this is 81, this should also be 81. 81 alternate segment theorem. Now I want to find angle Z. Try to find this angle first. 180 minus 42 plus 81. 180 minus, bracket open, 42 plus 81, it gives you 57. If this is 57, then use the cyclic quadrilateral property. 180 minus 57, it gives you 123. Opposite angles in a cyclic quadrilateral are supplementary. CBD, you remember that this angle is always half of the central angle. 24 divided by 2, 62. So angle at the circumference is half of the angle at the center subtended by the same arc. So that is 62. BAD angle. BAD, this angle is to be found. Um, let's see how can we find it. I can find this angle because this is isosceles triangle. So let me find 180 minus 124. It gives me 56 divided by 2 will give you 28. So this is 28, boys, and this is also 28. How did I get it? I get it this by 180 minus 124 divided by 2, 28, 28. Now this total angle will be how much? 35. 180 minus 35 plus 28, it gives us 117. So this is 117, which is equals to 180 minus 35 plus 28. So which property I have used? BAD, I found it 117. I used two properties. Number one, I used isosceles triangle property. You may write the full property. Opposite angles of equal sides, they're also opposite angles to the equal side, they're also equal. I wrote here isosceles triangles property. The second is I use cyclic property, cyclic quadrilateral property. Quadrilateral property. You should write it in the exam. That what is the cyclic quadrilateral property? The opposite angles in a cyclic quadrilateral are supplementary. Here in this question, he gave you this, and circumference is to be found. SQ is a diameter. So this is 42, boys. And this is 90 degrees. I can use SOHCAHTOA. How? This is opposite. This is adjacent. And this is hypotenuse. So I want to use hypotenuse and adjacent. It means I need to use kah. I need to use kah. So which thing is required? I want hypotenuse. SQ is required. So hypotenuse is required. So adjacent, which is 5.9 divided by the cosine of 42. What is the answer? We got it. 5.9 over cosine of 42 gives you 7.94. 7 point, I think write it to the four significant figures. 7.939. And take the half of this because this is diameter. So what is your radius? Take divided by 2. It gives us 3.97. Now circumference, just 2 pi r, 2 pi 3.97. into pi. It gives you 24.9. APQ, APQ, isosceles triangles. This is 38. I can find the central angle. So how can I do this? 180 minus 38 plus 38. So 180 minus sum of 38 and 38, 104. So the central angle is 104, and the back angle on the circumference is the half of that divided by 2. So 104 divided by 2 is 52. Next, B part, we have another isosceles triangle, but use the tangent alternate segment theorem. This is 50, and we have two sides equal. This is also 50. We can find this angle. This will be 80, and we can find this angle. That is 100 by cyclic quadrilateral property EFC. EFC 80 degrees, and CDE cyclic quadrilateral property, that is 100. 33rd question. um, we want to find BAO. BAO, this angle is required. You remember, guys, OA is radius and BA is tangent. So 90 minus 61, 90 minus 61 gives you 29. And once you find this 29, you have AOC. AOC, the central angle is required. So if you want to find the central angle, we need to find so let me, which property can be used here, because how much marks it has? It has 2 marks. Let's check. uh, 180 minus sum of 61 and 55, it gives us 64. So this angle is 64, and this angle is 64, and the double of 64 is 128. So we found it. That's why it was having 2 marks. ABC. ABC, did we find it? 64. We already found it. Next, CDA. CDA, cyclic quadrilateral property. 180 minus 64. 180 minus 64. So this is 116. 116. Next, we have this type of a circle in which the 80 degree, this is given to us, and we want to find u first. So get this angle, which is 100, because total is 180. Cyclic quadrilateral property, so this is 80, and this is the double, which is 160. So 80 and 160. Next, guys, I think this is the fourth question, came on the same topic, and we have a chord GH. The chord is 10. Chord is 10, and we want to find a perpendicular length. So perpendicular cuts them into half half, so 5 5. The radius is given to us. Oh wow, the radius is 8, and I want to find this perpendicular length. Use Pythagoras. Square root of 8 square minus 5 square. So square root of 8 square minus 5 squared, it gives you 6.24. 6.24. So 6.24. Next, he gave you two triangles. Um, it's a similar triangle. Because, guys, can I show you why they are similar? This angle is the same as this angle, and this angle is the same as this angle in the same segments, and x is the vertical opposite angles. The two triangles are similar. Now, if the triangles are similar, in front of the red angles, let me check which side I want to find. I want to find mn. I want to find mn. So mn is x, and the opposite to the red angle is 9.7. So x versus 9.7, and in front of the golden angles, 2.5, and x. Which one is 2.5? And x 2.5. Yeah, you have to take those sides which are opposite to the same angle. So take those two sides which are given to you. So the sides which are opposite to the golden angle, they are given 2.5 and 4.8. 2.5 and 4.8, and then do the cross. So x is equals to 9.7 times 2.5 over 4.8. That gives you the answer. Now this question, uh, these are again similar triangles. Let me explain you how. This angle is the same as this angle. Angle R is the same as angle Q. This angle, vertical opposite, is the same as this angle. Do the comparison. The areas, one area is 5 over 12 x minus 1. The second triangle which is given to me, uh, YRS. This is the small triangle, and this is the big triangle. So small is here, and compared with the big triangle, whose area is x and x plus 1. Now, my friends, what are their corresponding sides? For the small one, it is x. Both are in front of the red angles, x, and the big one is 2x. Clear? I need to put the square on the sides if I want to put square. If I want to put the square root, then I put it on areas. As you all remember, in similarity, we do it like this. So go ahead, guys, and try to solve this equation. Now 5 over 12x x minus 1 is multiplied with 4x squared, because this is 4x squared, is equals to x squared multiplied with x plus 1. Now 5 over 12, we get 4x cubed. If you allow me, x cancel with x square cancel with x square. So what is left to me? Just 4 and x minus 1 is equals to x plus 1. Easy. Now cancel 4 with 1, and this is 12, 3. So 3 goes to the other side. So 5x minus 1 and 3x plus 1. Open them. 5x minus 5 and 3x plus 3. So 5x minus 3x is 2x, and this is 8. So x is equals to 4. We did it. Parallel lines, 26. So this is also 26. Isosceles triangles. So this side is y. So this is also y. Can we get it? 180 minus 26 divided by 2. 180 minus 26 divided by 2 gives us 77. So both angles are, this is 77, and this is also 77. So guys, what these angles are equals to, this angle is the same as this, I must say x is equal to 26 plus 77. Then you write down the angle over here. Angle y we want to find, tangent and the chord is given, so I'm going to write this as 58 tangent segment, and this is also 58 tangent segment, and then y will be equals to the sum of the two interior angles, 58 plus 17. So 58 plus 17, it gives us 75. Oh wow, why 5 marks he has given? It's quite interesting, boys. Show that each interior angle of a regular pentagon, boys. Regular pentagon. Pentagon means the number of sides are 5. My favorite triangle. 360 exterior and interior. Number of sides are given to you 5. I can find exterior. 360 divided by 5. 360 divided by 5 gives me, so the exterior angle is 72, the interior is supplement of exterior, so 180 minus 72 will be 108, and it is shown. Next, pentagon is inside it. I want to find BM, the half of this, the radius. The radius is given to me, the radius is 12. Okay. um I want to find BM. Is there any side given to me? BC is given to me or not? Let me check. Let me check. Okay, is the angle given to me? Yes, the angle is given to me. The total angle, yani guys, yani interior, I have already found it. That is 108. So if this total angle is 108, if this is 108, can I take the half of that? 108 divided by 2 will give me 54. So this is 54. So if this is 54, use Sohkatua, guys. And I want to find, I can draw the triangle here. So this is O, and this is M, and this is B. So he gave you this is 54, and OB is 12. Hypotenuse is given, and I want to find adjacent. So Kah will be used. So Kah, and what I want to find the adjacent. So adjacent, if you want to find hypotenuse is given. So cosine of 54 times the hypotenuse, which is 12. So cosine of 54 times 12 will give you 7.05. We want to find bx. So if you want to find bx, because omx and abx are the straight lines, he has made us to find 7.05. This one, 7 point, we found it, 7.05, and the radius is 12. Now we want to find bx. You remember he said that om is cutting at the midpoint, so it means this is 90 degrees, boys. This is 90 degrees. This is 90 degrees. If this is 90 degrees and this angle is known to me, which angle I'm talking about? This angle is, uh, we found 108. Can we find this angle, opposite angle? So that, which is 72, I think. That should be 72. Now, 72, again, I can use Sohkatua. So this is your opposite, and this is your adjacent, sorry, hypotenuse, because it is in front of 90 degrees. And the adjacent is given to me. Can I use again cosine? Because angle is given to me, or sine. Now I can use, I want to find hypotenuse, and the adjacent is given to me, which is 7.05. So adjacent, and hypotenuse given to me. So cosine of 72 degrees, cosine of 72 degrees is equal to adjacent, which is BM, 7.05. Can I write it to the four significant figures? 0.53, which is adjacent, over hypotenuse, which is BX. So I'm going to write BX is equal to 7.053 over cosine of 72. Use the calculator. So divided by cosine of 72. Guys, I'm so tired now, but I need to finish the sheet. 22.8. Yeah, so this is done. So three significant figures. I found it. Now I want to find the area of AOX. AOX. This area is to be found. So if you want to find area, what are the things required by me? Uh, my friends, very, very interesting question it is, because to find the area of the triangle, you need to know the sides. This side is 12. This side we can easily find it. How? Because BC side is the same as AB side. Did we find BM? So BM, would you just take the twice of that? So 7.05, 7.05 times 2 will give you the 14.1 is the side of the pentagon. Every side is 14.1. So this is 14.1. BX, I found it as 22.8, 22.8. And the angle here is, I think we did it already. What was the half of 108? 108 divided by 2 gives us 54. So this angle is 54. So half time one side, which is 12, the other side is 14.1 plus 22.8. This is the second side, sine of the angle between the two, which is 54. So whatever the answer comes, you write it over here. Question number 37, EBD. Excuse me, guys. So EBD, this angle is to be found. So which thing I can use? EBD. Which property, guys, can be used here? Okay, let's move through isosceles. This is 28. So this is also 28. We can find this angle, 180 minus 28 plus 28, and close the bracket. We get 124. So this is 124, and B is the half of 124, which is 62. So let me write the reasons. Number one, property of isosceles triangle. Second is angle at the circumference is half, and then you can complete it. BAD, sorry, EAD, this angle. So if we want to find this angle in the same segment, because he's using ED, this angle is the same as this angle. So this is also 62. Angle in the same segment. BEO. BEO. Okay, let's see. How can I find it? This is 62. And we want to find this angle. Cyclic quadrilateral property, 100, 180. You just subtract 109. And also you subtract 35. And also you subtract 28. That will give you, so 180 minus 109 plus 35 plus 28, it gives you 8. So this is 8 degrees. We use the cyclic quadrilateral property. I'll show you how did I do this. Cyclic quadrilateral property. You can check that. I use this, then this angle, and this angle I used. In regular polygon, interior and exterior, interior is 11 times. Everyone remembers interior plus exterior is equal to 180. He said interior is 11 times. So 2e plus e is equal to 180. So e is equals to 180 divided by 3, which gives you 60 degrees. So exterior is 60. According to this triangle formula, exterior 360 and number of sides we want. So number of sides will be 360 divided by 60. It gives you 6. Sum of the interior angles of this polygon. If you know one interior is, which is 2e, so 2 times 60 is equals to 120 is the interior. How many sides it has? It has 6 sides, so just multiply them. 120 times 6, it gives you 720. There is another property, which is the formula n minus 2 times 180. So 180 times 4 will also give you 720. Any approach can take you towards the final answer. Question number 28. Exterior angle is x, interior is 8x. You know interior plus exterior, they are supplementary. So this is x and this is 8x. This is 180, so 9x 180, so x is equal to 20. So after finding this, we want to find the number of sides of a polygon. 360 exterior, number of sides, so number of sides 360 divided by the exterior angle, which was 20, so number of sides are 18. This is 58, this is 90 degrees. CDB, and I can easily find it. 180 minus 90 plus 58. This is 48. What is this? No, 48. Half. 48 divided by 2, it is 24. So this is 24. And this is alternate angles 48. OPR. OPR. So this is 48. Z concept. This is also 24. Radius of the circle is 5.4. And calculate the length of the major arc PQ. So we want to find the length of the major arc. Basically, the major arc is this. This is the major arc. Can I find the minor arc first? Minor arc. What is the central angle? 48 divided by 360, 2 pi, and the radius is 5.4. Once you get this minor arc, your major arc will be from the circumference 2 pi 5.4, you subtract the minor arc, and that will be the answer. So this is your circumference. Because everyone remembers, this is P, this is Q, this is minor arc, and this is major arc. So minor arc plus major arc is equal to the circumference. 39th. So this is an octagon, and it has all the sides same. Four of the interior angles are 32, 32, 32, 32. And if the angles are same, we want to find the angles here. My friends, to reach this problem, I need to know these four angles. Obviously, they are same. So I call them y, y, y. Octagon. Octagon. Number of sides are 8. What is the sum of the interior angles? 8 minus 2 times 180. So let me write here how many 32s we have. We have four 32s plus we have four y's, and their sum is equal to 8 minus 2 times 180. Let me simplify this equation. 4 times 32 gives you 128. 128 plus 4y, and then 6 times 180 gives you 1080. 1080 minus 128. Okay, and then divided by 4 gives us 238. So our x is our y is 238. Sorry, this is not my answer. Y is equals to 238, and you remember y and x, their sum is 360. This is y. So 360 minus y, 360 minus 238 will give you x. So 360 minus answer 122. Last. This one, guys, this is y. So this is 2y. So 2y plus 2y minus 60 is equal to 360. 4y is equal to 360 plus 60. And then 4y is equals to 420. And y is equals to 420 divided by 4, 105. So 105. Found it. Next, he gave us, uh, we want to prove that AOC is 104. AOC is 104. Obtuse or acute? The acute one. We want to prove that AOC is 104. 104. It's easy, guys. First, find this angle because it's a cyclic quadrilateral. It's a cyclic quadrilateral. If you know 128, can I find this angle? 180 minus 128. 180 minus 128 gives you 52. So this is 52. And then take the double of that because the central angle is always double. So 52 times 2 is 104. And give a reason. Angle at the circumference. Angle at the center is double. And this is cyclic quadrilateral property. BAO. Which one we want to find? BAO. This angle. BAO. I can easily find it because I know this angle. So 104, 360 minus 104 gives us 256, the reflex angle. Now, since it is just a quadrilateral. I'm not saying cyclic quadrilateral because like some of all the angles in a quadrilateral is 360 degrees. So I want to find this angle. Can we subtract the other three angles from 360 degrees? So 360 minus 52 plus 30 plus 256. So let me write it here. 360 minus 52 plus 30 plus 256 gives us 22. So that is 22 degrees. Interesting question. 22. Now, I want you guys to go to the next ABD. ABD. So, this property, if we can see, ABD, uh, ABD, this angle he's asking you. Do we have any other angle given to us? We found this 104, this is 256, this is 30 degrees, this is 22, and this angle was given to us. If we look into this, this is 80, this is given to us 28. Did he join them anywhere? Yeah, did you see? It's 28. It's angle in the same segment because he's using the arc AB. So it's 28. So that has to be 28 angle in the same. That's why it was having one mark. Let's move on to the next. He said that the radius of the circle is 9.6. The total perimeter of the sector OABC. OABC perimeter. So perimeter. Number one, we have how many sides? Four sides. Radius is given to me 9.6, so 2 times 9.6 will be added. OA OADC sector. Can I highlight it? OABC sector. So OADC sector, 104 angle, we have to use the 2 radius, and now the arc length I have to add it. Arc length is 104 divided by 360 times 2 times pi, and the radius is 9.6, and then we get our answer. Now similarity, guys. The areas are given. No, the volumes are given. I want to find the cross-sectional area. So area versus volume. The two volumes are given, 648 and 2187. Smaller prism is 36 area, and I want this. So you have to put 2 over 3. Because when the volumes are given, you have to write 2 over 3. If the areas are given, then 3 over 2. And then do the cross multiply to get the value of x. Larger prism is melted down into the sphere. So the volume is 4 over 3 pi r cubed. He will always provide you the volume of a sphere formula. So the volume of a sphere, larger prism. Where is the larger prism? The larger prism volume is 2187. 2187 is equal to 4 over 3 times pi times radius. Send everything to the other side. So 2187 times 3 divided by 4 pi, and then take the cube root to get the radius and write the answer. Last question, guys, then I'm done. V. We want to find the central angle. You know, the guys angle at the circumference is 45, so the V is double of that. So V is 75 times 2. 75 times 2 gives you 150. So this is 150. Now, we can find W very quickly because this is isosceles triangle. Uh, 180 minus 150 divided by 2 will give you W. So 180 minus 150, 30, and divided by 2 will give you 180 minus 150 divided by 2, 15. So that is 15 degrees. So 15. This is also 15. Total is 15. Next, we want to find x. Where is x? Uh, why is this angle is 30? Because the total is 130, and this is the half of that. So that should be 15. By the way, no need to do this practice. You know the angle in the same segment. This was 15, so that has to be also 15. Then he's asking you what is y. um, Guys, can I get this angle first? This angle is basically um, 180 minus 15 plus 85 plus 75. Add all the angles and get this. Did we find y before? We find y, I think. No, y we want to find. So if you want to find y, I need to know this angle which I'm trying to find. So let's try. 180 minus 15 plus 85 plus 75. So it gives me 5 degrees. So this angle is a very small angle, that is 5 degrees. So y will be equals to 15 minus 5, that is 10. So y is 10. Two containers are similar. Oh wow. So the areas are given and their volumes. So I want to find volume. So let me write here areas 94, 226. If the areas are given and you want to find volumes, you always write power 3 over 2. And volume of the larger one is 680. The smaller one I want to find V. Do the cross multiplication. So V is equals to 680 times 94 raised by 3 over 2 over 226, 3 over 2, and then you get your answer. Thank you, boys. I am done finally.